Hello everyone. Today we are going to start the topic of statistics. Well, statistical analysis, statistics, is a method for collecting data, organizing your data, analyzing your data, making sense of your data, and even drawing conclusions based on your data. So when you start a research work from the beginning till the end, you're working with statistics. Population, is a set of, all people or objects that you want to describe or analyze. Okay, so I'm gonna just go over some definitions. Okay, one is population, and sample is a subset or subgroup of your population. Okay, for example, I want to know what students in Genet 1101 think about the online activities. So I have a population, all the students who take Genet 1101, and I can create a subgroup sample. For example, I can just focus on the students who volunteer to participate in my research work, right? For example, let's say 80 students volunteer to participate in my research work, so I have a sample of 80 students. Well, um, we have different kinds of sampling, and when we are talking about evaluating information, we're gonna talk about that briefly. And if you look at the PDF book, the scientific method chapter also talks about different kinds of, sampling. So, regardless of any technique that you use to choose your sample, it's like, your sample should actually exhibit the characteristics of the population, of the target population. So, like in my example, if I have a sample of 80 students, these 80 students should represent, the population of students who take Genet 1101, right? I cannot just choose the students who have not taken Genet 1101, right? So, what is frequency? So, frequency is how often something happens. For example, let's say Eric plays football on Monday, Wednesday, and Friday. His team has scored the following numbers of goals in the recent games: 2, 3, 1, 2, 1, so on. Okay, so once they score 2 goals, another time 3 goals, then 1 goal, right? So a piece of data, we call that a data item. For example, 2 is a data item. Okay, 4 is a data item. If I want to see how often a data item happens, right, I call that frequency. Okay, for example, how often one occurs, score one. If you look at the data, you see that the score one happened twice, right? So the frequency of the score one is 2. How often 2 occurs? If you look at, the score 2, so we have 2 here, we have 2 here, 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 and here, right? 1, 2, 3, 4, and 5. 5 times. So score 2 happened 5 times. So 5 is the frequency of score 2. So instead of just presenting data like this, I can actually create a frequency distribution. Okay, well, it gives, a better idea what's going on, the frequency, to know, the frequency of each score. Just like here, instead of, presenting like that, I can actually create a table like this. So one column shows the score and the other one shows the frequency. Now it's easier, right? You can see that score 1 happened twice, score 2 happened 5 times, or score 4 happened twice, right? 2 times. Well, for example, look at this. These are just made up numbers, okay? So let's say this this data shows final score grades for students in Gen Ed 1101 in fall 2017. So as I said, just made up numbers, okay? Made up data. Well, if I give you, this data, it's very hard to see how many students got C, how many students got A. So it's better to use actually, frequency distribution to present the data, just like here. Now it's better, right? So you can see that 7 students, got score A. 12 students, got C, and 2 students, failed the course, right? So as you see, it's better to create a frequency distribution just like this table. Well, we have different kinds of frequency distribution. Let's say instead of A, B, C, I have, the scores like 82, 47, 75. So let's say these are test scores for a class of 40 students, right? It's really difficult to see how well, the students did on the test. So I can actually use the frequency distribution, okay? Well, one thing is that I can group some scores together. In that case, we have grouped frequency distribution. That's what we do actually. For example, I can say that for the scores between 91 and 100, I create one group and then assign A to this group, and I create another group 81 to 90 and I call that B, and I assign C to the group of 71 to 80, right? So just be careful that each score just actually, is located in one group. There shouldn't be any overlap, okay? Be careful about that. Well, in that case, I can actually create, a group frequency distribution, right? So be careful. For example, 40 to 49 is one group. 50 to 59 another group, okay, and so on, and the last one is 90 to 99. Be careful, each score lies only in one group, is located only in one group. One score cannot be actually located in two groups, in more than one group. There is no overlap, okay? So in that case, I can present the data like that. 40 to 49. As you see, 3 students, they got, grades between 40 to 49. 6 students got a grade between 50 and 50 to 59. 11 students, they got grades between 70 and 79, right? So one thing very, very important is that when you add the frequencies, right, that is the total number of data items that we have, okay? So the sum of the frequencies here is 40, which is the original number of data items, okay? So when you add all the frequencies, guys, I use sigma. Sigma represents, sum, addition. So sigma frequency, if I add all the frequencies, right? So sigma means adding. So I get the number of data items, okay? So it's equal to the number of data items. So I had 40 scores because I had 40 students. When I add the frequencies here, I get actually 40. Okay? So the question says, what class has the greatest frequency of the student's score? So the greatest frequency is 11, so it's related to the group of 70 to 79, right? So the class or the group of 70 to 79 has the greatest frequency of the student's scores. Well, we have some definitions. One is lower class limit. When you look at the classes that we have, the groups that we have, the leftmost number in each class of the group frequency is called the lower class limit. Okay, for example, if I look at the class of 40 to 49, the leftmost number is 40. So 40 is called the lower class limit. Okay, so 40 is the lower class limit. Okay, if I look at the class of, let's say, 80 to 89, okay, 80 is actually the lower class limit. We have upper class limit too. The rightmost number in each class is called the upper class limit. For example, if I'm talking about the class of 60 to 69, 69, okay, the rightmost number in this class is called the upper class limit. So 69 here is the upper class limit. Or if I'm talking about 90 to 99 class, 99, the rightmost number is the upper class limit. Okay, now we have another term that is class width. Okay, that's really, really important. If I want to find the class width, what should I do? Okay, first of all, I choose any two consecutive classes. So I choose two classes that one is right after another one, just like here. Okay, so we have 60 to 69, and the class right after that is 70 to 79. Okay, if I take the difference between these two consecutive lower class limits, I find the class width. So 70 minus 60 is actually 10. So 10 is my class width. You can do actually something else. So choose two classes that one is right after another one, okay? Just like here, 60 to 69 and 70 to 79. And actually take the difference between the consecutive upper class limits, these two. So 79 minus 69 is 10. As you see, I got the same number. So the class width is 10. Okay, well, I can choose another two classes. For example, if I go with, 80 to 89 and 90 to 99. So two classes that one is right after another one, they're consecutive. And then I find the difference between the upper class limits here. 99 minus 89 is 10. I got the same number, right? So the class width is 10. Here we go. 10 is the class width. When you want to find the class width, it's better, to choose the classes that you have here. Don't choose the first one or last one, because sometimes the last one I can go from 90 to 100 instead of 99, okay? So here we go. And be careful that, as we said, each data item must fall into exactly one class. So there is no overlap, okay? Because when you add the frequencies, you're supposed to get the number of data items, okay? So there is no overlap. Each data item must fall into exactly one class. So besides presenting your data in a table, as frequency distribution or group frequency distribution, we can use the graphs too. So histogram is an example. Well, as you see here, if we go back to the, soccer scores, the example of, soccer scores, for example, we know that the score 1 has frequency 2, so I have actually created a graph. So x-axis shows the scores, and y-axis shows the frequency. So score 1 has frequency 2. Here we go. We have a bar here that is showing that. And as you see, score 2 has frequency 5, right? So we have a score 2. So the frequency is 5, as you see here. So we show that using a bar. And so we can create a histogram. Here we go. You can also create a polygon. Well, when you have a histogram, okay, well, actually you can, on top of each bar, you can actually choose the middle point, okay? So choose the middle point on top of each bar, and then you can just connect these points. But don't forget to connect the first point and last point to the x-axis. Then when you remove the histogram, you're left with a polygon. Here you go. And as you see, you can see the frequency, right? So score 1 has frequency 2. Here it is, right? So on. So here is the polygon, frequency, polygon. Okay? So be careful when you see, people's data, when you're looking at media, when you see a graph. Well, it's really easy, to deceive people using visual display of data, okay? It's really important to be open-minded, okay? Always question your knowledge and the knowledge presented to you as well, okay? So, um, well, I'm gonna provide an example, how easy it is to deceive people using visual displays of data. For example, here, CNN USA, okay, in 2005, there was a graph on CNN.com, and it was like, based on what you have heard or read about the case, do you agree with the court's decision to have the feeding tube removed? And here's how they actually presented the data. Well, what is wrong with this? Actually, visual display of data. What do you think? We have the answers for Democrats, Republicans, and Independents. Well, the problem is that when you look at this data, well, just visually, as you see, you think that there is a huge difference between the response received by Democrats and Republicans and Independents, okay? This is how they have actually presented the data. But actually, here is the honest display of data. Because, for the Democrats, it's 62, for Republicans, 54, Independents, 54. This is how they presented the data. If you look at the y-axis, they didn't start from 0. Look at the scale, they started from 53. So in that case, just by looking, if you don't pay attention to the y-axis, you think that there is a huge difference between the response received by Democrats and Republicans, right? But honest display of data is here, right? It's not that different. So be careful about the data and the visual, presentation of data, right? It's very important to be critical. So, what I'm gonna do now, I'm gonna talk about measures of central tendency. Well, very, very interesting topic. Well, central tendency, average or typical in a variety of situations. So in the statistics, these values that they show the average, they show the typical value, right, in a population, in a sample. We call that, measures of central tendency. And, regarding the measures of central tendency, we're gonna talk about the mean, median, mode, and the mid-range. Okay, I'm gonna start with the definition of mean. Well, mean is the sum of all the data values over the number of data items that you have in your sample. Okay, so as I said, sigma means adding sum, right? So that's the sum of all the data items that you have over the number of data items that we have. So let's say I have this set of data, right? And I want to find the mean value, okay? So mean value is the sum of all the data items over n. So sum of the data items, it means I need to add all the data items that I have, right? So mean value is then 5. I add all the data items. Add it to 12, 4 plus 5 plus 8 plus 6 plus 3 plus 2 plus, okay, plus 5 plus 6 plus 9. Add it to 11 and then I add it to 12. And then I divide it by the number of data items that I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 over 13. So use your calculator, see what you get. When I add all the numbers in the numerator, it's actually 88 over 13, so it's 6.77. So the mean value here is actually 6.77. That is the mean value. Well, how do you calculate the mean value when you're given a frequency distribution? Okay, in that case, when I want to find the mean value, I actually multiply each item by its frequency. Okay, I add the results and I divide it by the number of data items that I have. Do you remember when we have frequency distribution, the number of data items is actually the sum of the frequencies, right? Sum of the frequencies, which is the number of data items that we have, right? Okay. Mean values, sometimes we show that like this. So this bar that you see on top of x means we are finding the mean value. Okay, so let's see how we can find the mean value when we have a frequency distribution. Okay, so well, let's say we have done a study. We have asked some students that, how stressed have you been in the last 2.5 weeks, and just rate it on a scale of 0 to 10. 0 like, not stressed at all, and 10 being, as stressed as possible. And here are the data that we have. For example, 2 students said that they have no stress at all. One student rated his or her stress level as 1. 3 students reported 2, right? 2 of the students said that, their stress level is 3, and so on. Okay, we want to find the mean value. Okay, what I'm gonna do, as you see, it says, the mean value is each data item times its frequency over the number of data items. Okay, so I need to multiply each score, each actually a stress level, by its frequency. 0 times 2 is 0. 1 times 1, right? And then I add the results. And n, the number of data items, is the sum of the frequencies, right? If I add all the values in this column, the column of frequency, I get n, right? So this is what I do. I have the stress rating, I have the frequency, I create a column for x times f, each data item times its frequency, just like here. Look at the first row. Stress level is 0, frequency is 2, 0 times 2 is 0. Second row, stress level is 1, your score is 1, right? The frequency is 1, 1 times 1 is 1, and so on, right? So when I have each item times its frequency, then I add them. Okay, so 0 plus 1 plus 6 plus 36, I add all the values that I have here, so that's the numerator. So in this case we get 975. Okay, I want you to actually at home, I want you to practice and add all these numbers. Make sure that you have the same number, 975. That's the sum of the frequency times the data item, right? Okay, so frequency times data item, add all the results. That's your numerator, 975. And n, the number of data items, is actually the number of frequencies that you have. When you add all these values, you get n. When you add them all, is 151. So the mean value is 6.46. Okay. Before moving to median, I'm gonna stop, give you a break, think about the materials we have talked about so far. So we will be back to talk about the median. Thank you.